Hi, okay, so today I'm going to talk about the differences between threading, async await, and just standard processing. I'm not going to focus on languages, for example, C# and .NET. What I'm going to do is just talk about it in a general terms. Okay, so let me give you a real world example of the differences between the three different things. So first of all, normal processing. Imagine you've got a kitchen. Okay, so you've got a restaurant, and in that restaurant you've got one chef. Now the chef basically uses frying pans to cook everything. So basically, and he does the cooking. So basically, standard processing is somebody comes in, orders a starter. The chef will take the order, go and get his frying pan, cook the starter in the frying pan, serve it. While he's doing that, somebody orders the main course, somebody orders the dessert. Now basically what has to happen is the main course processing has to wait until the chef has finished the starter in the frying pan. Then what he'll do, he'll go to the main course, you'll get the order, he'll cook the main course in the frying pan while he's there, he'll finish it, serve it, then he'll go and he'll cook the dessert in the frying pan, serve it, and then go along. So in essence, as you can probably see from there, or as you can probably gather, as you probably gather, that's price inefficient. So it's one person standing there doing each task one at a time, all the way through. So that's standard processing. So now let's take it to await async. So what await is, it's tasks. It's one man again, but it's basically a collection of tasks. We can imagine, again, same scenario. You've got a restaurant, you've got a main course, dessert, and a starter. So what the chef does then is he buys 3 microwaves. So async, await async is a microwave in essence. So what he'll do is he'll get an order for the starter. He'll go away and prepare it. He'll put it in the microwave, he'll set a timer, and then he'll walk away. You'll then start working on the main course. He'll put it in the microwave, he'll set a timer, he'll walk away. You'll then go start working on the dessert. He'll set a timer, and he'll walk away. The starter will ping. He'll go back and he'll finish the starter and serve it. The main course will ping. When it's cooked, you'll go back, you'll finish preparing it, and he'll serve it. The dessert will ping. He'll go back, he'll finish preparing it, and he'll serve it. So in essence, that's async await. As you can see, it's a lot more efficient than using standard processing. In essence, where the chef's got to stand there, cook the thing in the frying pan, can't move away, do anything else. You've got to stand there and do it. With a microwave, you can start it, set a timer, go away, and it'll ping when it's ready. Okay, so that's the difference between standard threading and async await. Now let's talk about threads. So what a thread is in essence, that's a concept of workers rather than tasks. So instead of having 3 microwaves, what it does, it goes, okay, I'm not happy with microwave food. I want to basically, it's cooking, but it's still taking me time as well. The quality's not really there, and it's taking a long time. So basically what it does, he hires 3 chefs, which are called workers, which basically threads. So what he'll do is then, in essence, you'll have one person stood there, and what he'll be doing is he'll be doing main courses. So as soon as the starter comes in, they give it to the starter chef. The starter chef will start cooking it, preparing it on the frying pan, and then serve it. Basically, the same goes for a main course worker, and the same goes for a dessert worker. So as you can imagine, basically, in essence, that's a lot quicker. So basically, you've got one thread, one worker at a time, doing each course. So obviously, that in essence, what you can do is then they can all be working at the same time. So in essence, you can start the starter, the main course, and the dessert at exactly the same time. One might take longer than the other. So basically, you can time work it out where basically it's finished. So basically, what in essence is every thread's finished by so the main course is ready when the starter's finished. The dessert's ready when the main course is finished. So in essence, what that does is it's called parallel threading. That's the difference. So you've got a worker and you can run them in parallel. In essence, so you've got all 3 of them in parallel. What threading also allows you to do is basically then, okay, that's really, really good. So you've improved performance dramatically then from basically just having one chef doing everything on a frying pan to having microwaves where you can walk away and then go back to having 3 chefs. But what you can do then is, in essence, is taking the parallel threading a little bit further. You can hire 50 starter chefs. You could hire 50 main course chefs. You could hire 50 dessert chefs. So in essence, what you can see is you can then basically process a huge amount of orders really quickly in time. So in essence, that gives you a good example of how you work with the different terminologies in regards to threading. So what you've got as well then is, in essence, with Docker containers, is then what you've got with the Docker container is another concept. So as we saw before, we've got the standard processing, async await, threading. What we've also then got is we can instantiate new instances of Docker containers as well, a bit like a threading terminology. So what it is then is you can create a new kitchen. So you can imagine you get orders in, you've got one kitchen, which is one Docker container. You can then basically, as you get more orders in, you can spin off a new kitchen. As you can imagine, that's going to cost more. It's going to be more time consuming. It's going to be more data. It's going to be more intensive. But in essence, you get in the full. You can in essence replicate a kitchen over and over again using Docker instances. So basically, that is another concept above threading. So all four of them really have got their own benefits and their own uses from when it's useful. But in essence, I hope that gives you a good understanding of the difference between different types of threading and Docker instances. I'll post another video next week. Thank you very much.